In this part, we are going to work on the player camera. That way, we can look around. You might be wondering, why do we start with the player camera? And the answer is, well, for the player movement, we need the camera. So we have to start with that. Later on, when the player moves forward, we want to move forward in the camera direction. So if we don't have a camera, we can't really do the movement properly. On top of that, for the camera, I either want to have a control via the controller or by a mouse. Finally, the camera should be a physical object, meaning it shouldn't be able to disappear inside of a wall. For all of that, back inside of Godot, we currently have a camera 3D inside of the player scene, which I do not want, so let's get rid of it. And instead, I want to create an entirely new scene, where the root node is a spring arm 3D. This effectively is, a spring arm, so an arm that can be extended and compressed. The length of it is set by the spring length. At the moment it's 1 meter, but I want this thing to be 6.5. To the end of this arm, I want to attach the camera 3D. Also make sure that you set this camera to current. Once we have that, we can save the scene inside of scenes and characters, and I realized I should have renamed the node. This should be called camera controller. Like so. Then save the entire thing inside of scenes and characters or wherever you prefer. And after you have that, inside of the player scene, you want to add the camera controller. With that, we have the camera at the bottom of the player, which isn't ideal. To fix that, inside of transform, you want to give it a height of 1.4 and make it point down on the x-axis by -25 degrees. That way it's looking down. And if you go into the game scene and run all of this, because of the spring arm, the camera is going to be pushed out. So we are 6.5 meters away from the player, or whatever you have set inside of the spring arm, this value here. That covers the basics. Now we have to make this thing interactive, which we do by adding a script to it. All of the defaults here are fine. And now we have to set a couple of default values. All of those I want to export. First of all, I want to have a var min limit x, which is going to be a float that by default is going to be -0.8. After that, we can duplicate all of this and then create a max limit x, which should be -0.2. This would limit how far the camera can go up and down, or rather how far it can rotate along this axis. You see in a bit what I mean. Besides that, I want to have export var horizontal acceleration. This also needs to be a float with a default value of 2. We also want to have a vertical acceleration that should be a bit less, 1. And finally, I want to have a mouse acceleration. This value should be really small, 0.005. With that, we get some basic camera limits and the acceleration, how fast the camera can move. After we have that, I want to get actual input, which I first of all want to do via a process function. In there, we're going to get controller input, which I would recommend to use, but in just a second, I will also cover mouse input. So you can use either. In there, first of all, I want to capture some kind of input, which I want to store inside of joy direction. This value we are going to get via input and get vector. Via that, we're going to get the right joystick on the controller. The 4 directions I have covered via pan down, pan left, pan right, and pan up. We have to start with the -x, pan left. Then we need the positive x, pan right. After that, for the -y, we need pan up. And finally, the last value, pan down. That will give us all of the 4 directions. Although before I can use them, I want to apply the horizontal and the vertical acceleration to them. On top of that, I also want to apply delta to it. For all of that, let's create another variable, var joy direction accelerated. All we have to do in here is get the joy direction, multiply it with delta, and then multiply it with a vector 2 that has the horizontal acceleration and the vertical acceleration. Finally, to actually apply all of this, I want to create a function called rotate from vector, where we are passing in the joy direction accelerated. That means we now have to create rotate from vector, where we have one parameter, a vector, which has to be a vector 2. First of all, in here, we want to check that we have some kind of input. Or in other words, if we don't have input, we don't want to do anything inside of this function, which we can do via if v.length is equal to 0. Then we want to return and end the function. However, if we do have a value, then I want to update rotation.y and subtract v.x. That way we are rotating around the y-axis. Now one thing you have to be careful here. The input we are getting from the controller is 2D, meaning we have a vector 2 with x and y. But this we want to use to rotate in a 3D space. So we want to get left and right on the right joystick on the controller and use that to rotate around this axis. Can be a bit confusing in practice. But I think once we have that, this should already work. Let's try. And inside of the game, I can go left and right. And that is working pretty well already. Besides that, to go up and down, I want to rotate around the x-axis. So rotate.x and then subtract v.y. If I do that, I can also go up and down, although you can see this gets very strange very fast. So not great yet. To fix that, we want to limit the x rotation, which we can do via rotation.x and then clamp the value. The value that we want to clamp is rotation.x. The minimum value is going to be minimum limit x, and the maximum one is max limit x. That way we can do all of this again, and now this is working much nicer. And alright, that's a pretty good start. Also at this point you can see if I rotate too much, at some point the camera is being pushed a bit in, roughly here. So it's a bit of a subtle effect, and I think I can make it stronger by going to the game level and then moving this platform up just a bit. Then you can see what the wall does a bit better. If I rotate, we always have a distance of 6.5 meters to the player. But if I go to this wall, the camera is being pushed in. And that happens because of the spring arm. Effectively now our camera is a physical object that can interact with the level. If we didn't have that, the camera would clip into the wall and it would look super weird. And well, with that, we have the camera rotation. That looks pretty good. Next up then. If you don't have a controller, you can also use mouse input, for which we are going to use func_input. And while we are doing all of this, I want to comment out the process function so we don't get accidental controller input. First of all, we want to check if there's any kind of mouse input, which we can do via if event is input event mouse motion. If that is the case, we know the mouse is moving. Just to test this, I want to get event.relative. This is going to give us the mouse movement on every single frame, or the relative movement on every single frame to be a bit more specific. Let's try it. And if I don't move the mouse, we don't get anything. But if I move it, we can see how much the mouse is traveling on every single frame. That value we can use. For that, I want to create a new variable. Let's call it mouse direction and accelerated right away. I want to get event.relative and multiply it with the mouse acceleration. Once we have all of that, I want to once again rotate from vector and get the mouse acceleration. Actually, this should be mouse direction accelerated. That makes more sense. If we now try all of this again, we should have mouse camera control. And this does work. That's quite nice. So we do get camera rotation. This also goes up and down. However, if the mouse goes outside of the window, like so, then we don't have a camera movement anymore. To fix that, what you can do is func_ready and input mouse mode captured. That way the window is going to capture the mouse. Now this is going to work, but the issue now is that we cannot use the mouse anymore once we are inside of the game. Let me actually demonstrate. If I now run the game, the mouse disappears or is always inside of the window. That means we cannot go outside of it anymore with the mouse, but we also cannot close the game. Now what you can do is you can simply Alt-Tab out of it and then close the game. That still works just fine. Although I guess what you would want to do is check inside of input if input is action just pressed, and then UI cancel. If that is the case, get tree and quit. That way, if we are pressing escape, we are quitting the game. Let's try all of this. I can run the game, I can look around, and if I press escape, the game ends. And this is how you would do basic mouse camera control. Now in my case, I want to comment out all of this and rely only on the controller for the camera control. With the camera in place, we can actually start working on the player movement. No animations or jumping yet, that we are going to work on later. For the player movement, the one part that we already have is the camera, so we know in which way we want to move. Although there's still going to be a difficulty that we want to convert to the input, meaning on the controller or the keyboard, we can only go up, down, left or right, but we want to move in a 3D direction. Whatever words up on the keyboard or the controller is going to be forward in the camera direction. Just keep that in mind, accounting for it isn't that difficult. Here we are back in Godot, and first of all, I want to close the camera controller script because we don't need it anymore, although do make sure that you are saving the entire thing. Then we can close the camera controller and work inside of game. First of all, inside of project settings and the input map, we have the actions for left, right, forward and backwards. For each of those, you have a key binding either for the controller or for a keyboard. And those we want to use. The logic for that is going to be primarily inside of the player class. However, inside of the character, since it's the parent, we want to keep some logic that we can later reuse for the enemies. Which means, first of all, inside of the character, I want to add a script. The defaults here are fine, create. And for now, all I want to do is to create two variables. The first one is an export variable. Let's call it base speed. Should be a float with a value of 4. Besides that, I want to have a var movement underscore input, which always has to be a vector 2. That is all we need inside of the parent class for now. That means next up, we want to work inside of the player. And now we don't want to use the character script. So the one that's attached to the player right now is incorrect. I want to get rid of it and instead add a new script. The defaults here, once again, are fine. But I do want to make sure that I still have all the stuff from the character. To get that, all you have to do is define a class name, in my case, character. And then we can inherit from this class, which means inside of the player, we want to inherit from character instead of character body 3D. Effectively at this point, we have created a new node. If you look for character, we have a character node that inherits from character body 3D. Not something we are going to need, but this is quite nice because now this character class has access to these two variables. And to use all of that, first of all, I want to create a func physics process in which we want to get a move logic function that needs to get delta as an argument. This function doesn't exist at the moment, so I want to create func move logic with a delta parameter. First of all, in here, we have to get the movement input, for which we already have a variable from the character, this one here. And to get the actual values, we want to get, once again, input get vector. With the 4 directions, we always start with -x, which is left, then positive x, which is right, negative y, which is up, and finally positive y, which is down. And make sure you get left, right, up, and down, and not UI up or down or left or right. With that, we have the 4 directions from either the controller or the keyboard. After that, I want to get the current velocity of the player and store it inside of velocity 2D. Now for that, we want to have a vector2 with velocity.x and velocity.z. Velocity is an inbuilt parameter of the character class, or well, the character body 3D class that we are inheriting from. This would effectively give us the current velocity on the xz plane, meaning we are entirely ignoring the y-axis. This one we are going to cover later on when it comes to jumping. For now, I only want to go left or right, so x, or forward and backwards, which means z. To actually use that, first of all, I want to check if we have movement input. Or in other words, if movement input is different from vector2.0. That way we know we have some kind of value in here. If that is the case, I want to update velocity 2D and add the movement input multiplied with the base speed that once again we are getting from the parent class, this value here. This we want to then multiply with delta time, and then we are getting acceleration, which we can then use to update the velocity of the player, meaning velocity.x is going to be velocity2d.x. The same thing we can do to velocity.z. For this one, we want to have velocity.y. Velocity.y is our controller input, meaning we are going forward or backwards. In the 3D space, however, forward and backwards is covered by the z-axis. So once again, we have to convert 2D input to 3D movement. With that, we should be getting something, although the movement now is going to be a bit rough. Let's just try. I can run the game and nothing is happening. And I think the reason for that is, if you look at the game scene, especially the player, we can open the scene in the editor, and that's kind of it. We cannot see a script attached to it. And that, I believe, is a bug inside of Godot. If you get rid of the player and add the very same scene again, player.tscn, then we're getting a script attached to it. And now we can run the entire thing again, and this should be working. And we are getting a whole bunch of errors. Not amazing. That is because at the moment the player is inside of the obstacles that we don't want, and also this should be a stair kind of thing, like so. Let's try all of this again, and once again the debugger is really unhappy. Let's check it, and we get inside of the input map down and up doesn't exist. Which means inside of the code, this up and down is incorrect. That is because inside of the input map, those are called forward and backward, not up and down. Sorry about that. This should be forward and backward. Next attempt. And now we don't get errors anymore, and I still cannot move around. The issue we have now is that we are not calling move and slide. Next attempt. Now this should be working. And now I can move the player around. We are accelerating, and I can go in different directions very slowly, but we are accelerating. And eventually we are moving around. Couple of issues here. First of all, this value is a bit too low. And to make this a bit more speedy, I want to create an export variable called acceleration. This should be a float with a value of, let's say, 8. And all of this I want to multiply with our movement change. Next attempt. I can now move around. We are accelerating much faster, although we are not stopping once we are moving. So once I start moving, it never stops. When we are getting the movement input, we are increasing the acceleration, or effectively the speed. But if we don't have movement input, we don't change it. So we never stop moving. To get that, we want to add an else statement, meaning we want to do something when we don't have movement input. And what we want to do is get velocity 2D and assign it a value that gets closer and closer to 0, which we get via velocity 2D and move toward. We want to move toward a vector 2.0 by a certain kind of speed, which in my case I have set to base speed multiplied with delta and then multiplied with another export variable, deceleration, which I have set to 4. This we want to use in there as well. And once we have that, we can duplicate these two values, paste them in there, and then we should be decelerating once we stop getting input. Let's try this now. I can move this way, and we are stopping very slowly once I stop moving with the controller. Now, this is kind of working, but effectively it feels like we are playing billiard. The major issue we have at the moment is that the speed of the player is uncapped. We can go as fast as we can, and since we are accelerating on every single frame, we are getting a lot of speed really fast. To fix that, we want to limit the length of velocity 2D. Or in other words, velocity 2D is going to be velocity 2D and limit length. The maximum length should be the base speed, so we can never go faster than the maximum speed, or the speed that we have defined. And with that, we are moving at a much more reasonable pace, while still accelerating and decelerating. So this is much better. That covers the basics of movement. There are two more things that I want to do. Number one, let me run this again. I can move to the right, like so, but this is not affected by the camera. So I can move the camera around while moving to the right, and we are always moving in the same direction. But this shouldn't be the case. Left, right, forward, and backwards should be relative to the camera direction. Meaning if I point towards the ring and press forward, we should be going towards the ring, which obviously doesn't happen right now. Besides that, the player should also rotate in the direction that we are moving in. Now to get started with the first issue, we want to get this input rotated around the camera rotation. For that, first of all, we need the camera. All the way at the top, on ready, var camera is going to be the camera controller, and in there we have the camera 3D. Once we have that, we want to get our get vector for the input and then rotate it by the camera rotation. That we can do via rotated, and in there I want to have negative camera dot global rotation dot y. If I run all of this again, I can, for example, look towards the ring, press forward, and we're moving towards the ring. I can look at this block, move towards it, move back, move left and right, and the movement is always relative to the camera position, or well, to the camera rotation. And that feels like much better input. So this is working really well. And to make this effect even better, we want to rotate the model itself. If we have input, I want to set a target angle, which we can get via the movement input by converting it to an angle. And once we have that, we want to rotate the character model inside of the player. We want to get the player skin and rotate it by this target angle. I guess to make this a bit easier, on ready, var, let's call it skin, is going to be the player skin, like so. After that, I want to get the skin of the player, get the rotation, and then the y-axis. I want to rotate this one toward a certain value. The start value is going to be skin dot rotation dot y. The target value is going to be the target angle. And then we need some kind of speed, which is going to be delta, and in my case, multiplied by 6. Let's try this one, and it's not going to work yet. So if I move, let's say, towards the ring, we are looking in the wrong direction. but we are rotating, just not in the right direction. So some adjustments and we should be good to go. First of all, this movement input angle should be negative. Let's try that. And then if I go towards the ring, we are nearly there. We are simply offset by 90 degrees. So if I go forward, the player's looking to the right. If I go to the left, the player's looking forward, and so on. Now to get an extra 90 degrees, all we have to do is add pi divided by 2. That way, all of this should work just fine. I can now move towards the ring, the player's looking at it, and I can go in all the other directions, and this is working super well. At this point, the player can move around, but that is still fairly limited, so for the proper movement, we also have to be able to jump and fall. For all of that, we are going to use some projectile math, which does get slightly more advanced. I won't go into too much detail, but if you are interested, check out this video, Math for Game Programmers, Building a Better Jump. This one goes over the math in a lot of detail and is super interesting. Here we are back in Godot, and I want to work inside of the script for the character. In there, we have to create a whole bunch more variables for the jump mechanic. To get started, we want to have 3 export variables that define the jump behavior. We want to have a var jump height, which should be a float with a default value of 2.25. This we can duplicate because next up we want to have a jump time to peak. Also float, and in my case the value for this one is going to be 0.4. Duplicate all of this one more time, and then we get jump time to descent. The value for this one is going to be 0.3. With these values, we can define how high the player can jump, how long it takes to get up to this highest point, and how long it takes to get down again. Although to actually use all of them, we have to do a bit more math. For that, on ready var, I want to have a jump velocity, which is going to be a float, and the formula we want to go with is 2.0 times jump underscore height. This we want to get inside of parentheses, and then divide the entire thing by jump time to peak. Once again, for the math, check out the video I mentioned earlier. All of this we have to multiply with negative 1.0. That way we are actually going up in the 3D space. Once we have that, we want to duplicate all of this and then define a jump gravity. The formula for this one is negative 2 times jump height divided by jump time to peak multiplied with itself. So jump time to peak. You could also square all of this, you would get the same end result. Finally, we want to do all of this one more time and then define a fall gravity. The formula for that is going to be negative 2 times the jump height divided by jump time to descent squared. So let me change both of these to descent. And there we go. With that, we have a jump velocity, a jump gravity, and a fall gravity. 3 values that we can use and that give us really precise jumps. Now the actual logic for the jump is going to be inside of the player script. For that, I want to create another function, jump underscore logic. We are always going to need delta in here. And then, first of all, we want to check if we are on a floor, which means if is on floor, meaning we can only jump if we are on a floor. After that, we want to check for a jump input, which means if input is action just pressed, and somewhere in there we have jump. If that one is pressed, we want to get velocity.y. This one is the velocity to go up and down in the 3D space. And the value we want to assign to it is going to be the negative jump velocity. The value that we are getting from the character class. This one here. That way, if we are jumping, we keep on going up forever. Let's actually try. I want to get the jump logic along with delta time, run the entire thing, and I believe to jump the buttons are A on a joypad. That works, and on the keyboard it would be space. good start, but obviously this isn't ideal because, well, we're never going down again. For that purpose, we want to create a variable called gravity, which is either going to be the jump gravity if velocity dot y is greater than 0.0. If that is not the case, else we want to have the fall gravity. Effectively what that means is if we are jumping upwards, we want to have this kind of gravity, and if we are falling, we want to have this kind of gravity. After we have that, we have to apply the gravity, which I want to put inside of another function, which means apply gravity, for which we are going to need the gravity we have just created and delta time. This function doesn't exist yet, and I want to create it inside of the character class, which means in there I want to have apply gravity with the gravity that we need and delta time. I want to have velocity dot y minus equal gravity multiplied with delta. That way later on we can apply gravity to the enemies as well. And you could also make them jump, although it's not something I am going to do. Let's try all of this. And now on the keyboard I'm pressing space and we are jumping very, very high. I realized I made a slight mistake. Inside of the formula for jump gravity and fall gravity, these values should be inside of brackets. So we are doing the division properly. Now let's try this again. I can press space and that feels like a much snappier jump. I can also move around. I'm only using the keyboard right now and that is working pretty well. The jump might be quite short, but I think it's good enough. Once again, play around with the values and see what you like. At the moment, the player can move around, but it looks really weird because we have no animations whatsoever inside of the game. That we are going to fix now. For the animations, though, we have a bit of a problem. There are a ton of animations that we have to manage, and that can become quite complex. Although, once again, Godot is really nice here, because the animation tree node makes all of this much easier. Although this node tends to be a bit more advanced, so I am going to go over this a bit more slowly. First of all, we have to create the animation tree. Since we are going to reuse that one quite a bit, I want to create it inside of the character class. In there, I want to have an animation tree. You can leave this one as it is, save the scene, and then inside of the player, we have the animation tree. For this one, we need two things, a tree root and the animation player. The animation player we are getting from the player skin. If you look at that, we have an animation player with all of the animations for this model. For example, in there, we have one hand ranged aiming that we can play, and we are shooting. These animations we want to manage via the animation tree. For that, first of all, we have to get the node. The easiest way of doing that is with the player skin, you want to have editable children. After that, you can simply drag the animation player into the animation tree, like so. We want to define the tree root, and in our case, we want to have a blend tree. If you click on that and look at the bottom, we now have an animation tree with a node system, where we have an output, and then if you right-click on this field, you can set animations. For example, if I add an animation node, I can click on the symbol and then select any of these animations. Let's go with one hand melee attack chop, just to try something. And then if I connect this to the output, we are getting an attack animation. That means the system is working, but I don't want to play an attack animation on its own. Instead, I want to start with a state machine that I'm going to rename to move state machine. Then we have to open the editor, and now we are in a different kind of node system. Let me expand it actually. We are always starting on this start position, and then we can go to an animation. If you right-click, you can add an animation, and in my case, I want to add, first of all, the animation called idle. And to this node, we always want to go automatically. For that, you want to click on this connect nodes, and then connect start to idle. This arrow tells us that we are going automatically from the default to the idle node. And then, back inside of the root, This state machine is going to play the idle animation, which we want to have as the output. If I run the game, the character should be idling, and we are. Although the problem now is that we are only playing the idle animation once, but we want to loop it. In our player skin, we have made this scene local, so all of these animations are only inside of Godot. Meaning to loop them, you want to go to the animation, let me find it, idle, and then you want to click on this symbol, animation looping. Now we should be playing the idle animation continuously. And we do. That looks good. I guess a small disclaimer, if you didn't make this rogue scene local, you could go to character, find the character that you use, in my case rogue GLB, then find the animation in there. Once again, we have too many animations. Click on idle, and then set the loop mode to linear. That way you could loop the animation without making the skin local. Although not something I want to do, so we can close all of this. Perfect. With that, we can work again inside of the animation tree of the player and work with the move state machine. In there, at the moment, somewhere, we have a start scene and we are going to idle. Besides that, I want to add another animation. And right now, if I right-click, nothing happens. That is because I have this transition symbol selected. You basically always want to have the mouse cursor selected, then you can right-click, add an animation, and in my case, I want to add running A. And effectively, we want to be able to go between the idle animation and the running animation. But this shouldn't happen automatically. It should only happen when we want it to. Because of that, you want to disable this auto button, and then be able to transition from idle to running A, and from running A to idle. So we can go back and forth between the two. Although that we have to manage inside of the script. For that, first of all, we want to get the move state machine, the one that we have just created, this one here. This we can do inside of the character. Once the scene is ready, on ready, we want to create a var move state machine, which we can get via the animation tree, the node that we have created. So animation tree. Or in other words, if I have the character open, we want to get this node. We want to get one specific node, which has the path parameters move state machine and then play back. The easiest way to get this parameter is if you look at the character scene, the animation tree, and then the inspector. In there, we have parameters, and at the moment, we have the move state machine. If you hover over playback, you can see the path that I have just used. And by the way, move state machine we are getting because I have called this state machine move state machine. You could call this whatever you want, but this name makes sense. Righty, once we have that, I guess we can also make sure that we are working with the types properly. This value should be an animation node state machine play back. Like so. That way, we always know what kind of value we are working with. And if you want to read it properly, it's animation node state machine playback. Once we have that, we can create a function to switch between the different states that we have inside of the state machine, which we can do inside of a function set move state. I want to have one parameter called the state name, which should be a string. After that, I want to get the move state machine and travel to that state name. And that's actually all we need. Once we have that, we can go to the player and inside of the move logic. When we are moving, we want to play the run animation, which we can now do by simply setting the move state to running underscore A. If we are not moving, that happens inside of the else statement. We want to set the move state to idle. And with that, we should be good to go, although there's going to be one issue that I see already. So right now, we're not moving, so the animation is going to be idle. If we start running, we are running, but this animation isn't looping. So we only play it once, and then we are back to a static thing, so not ideal. For that, we want to go to the player skin, the animation player, and find running A. Somewhere in here, there are a ton of animations running A, and this should be looped. With that, this should be looking a lot better. Now I can idle, and I can run continuously. That looks good. And go back to idle. This is working really well. Perfect. Although, if you look closely, if I toggle between these animations, it's really abrupt, which looks super bad. That, however, we can fix very easily inside of the animation tree. I want to go to the state machine, and then for these transitions, once again, make sure you have the cursor selected, then you can click on them, and then you can set an X fade time. That is the transition time between animations. I usually set this one to 0.2 for all of the transitions, so 0.2. And then if I run the entire thing again, we now have a short transition between these animations, which is looking a lot better. Perfect, that looks good, although we do have to define a jump animation as well. For that, back inside of the animation tree and the move state machine, I want to add one more animation, which is called jump idle. And then we want to be able to go from idle to jump and from running to jump and back again, which means we need a whole bunch more arrows like so. And for all of them, we want to have an X fade time of 0.2, which means for all of these arrows, you always want to change the X fade time . Can sometimes be a bit labor intensive, but there we go. Now we have a jump animation in there as well. You use that one inside of the player script. We want to go to jump logic and then check when we are jumping. This happens here. Oh, well, to be a bit more specific, we only want to check if the player is in the air, which we know happens if is on floor is false. As a consequence, we can add an else statement in here. And if the player is not on the floor, we want to set the move state to jump underscore idle. Let's try this one. I can still idle, run around, and if I jump, we are getting a jump animation.